A package of 7 kilograms sits at the equator of an airless asteroid of mass 3 times 10 to the 20 kilograms, and the asteroid has a radius of 6.9 times 10 to the 5th meters. So we want to launch a package off of this asteroid so it never comes back, and that when it is very far from the asteroid, it'll be traveling with a speed of 213 meters per second. And to do this, we have a very powerful spring whose stiffness is 3.0 times 10 to the 5th Newton meters. So the question is, how much must we compress the spring? First off, your system is going to be the package plus the asteroid plus the spring. And note that there is no work done by the surroundings, so your work external is going to be 0. Your given information, as underlined in the question, will be the mass of the package, the mass of the asteroid, the radius of the asteroid, the final velocity, and the stiffness of the spring. Let's get started. We're going to start with a fundamental principle, which would be the work energy principle. It has delta E equals work, but work equals 0, so delta E equals 0. Then you can split that up into the energy final equals the initial energy. You can expand that to get the kinetic energy final plus the gravitational potential energy final plus the spring potential energy final equals the initial kinetic plus the initial gravitational potential plus the initial spring potential. And then I expanded those into their separate formulas. And notice how 3 of the terms are going to be 0. The final gravity is going to be 0 because the package is no longer on the asteroid. The same with the spring, the package is no longer on the spring, and the initial kinetic is negligible. So those 3 terms will be 0. So, given that, we have this simpler formula. And from this simple formula, we're looking for S. How much is compressed? We're trying to solve for S. So, we will move here. We will add the initial gravitational potential energy, and then we will try and isolate S. What we're going to do is multiply both sides by 2, then divide by Ks, and finally you would take the square root of S to end up with S equals the square root of 2 times the final kinetic energy plus the initial gravitational potential energy divided by the stiffness of the spring. And that will give you your value for the compression of the spring in order to make it go away from the asteroid and never come back.